Alrighty, here we go. I'm assuming you're ready to go unless somebody says something. All right, let's do this. We're talking about angles. On that slide is a picture of a ray. What I would like you to do is write a definition of a ray. And remember, your definition should accurately describe the thing we're talking about, but should also eliminate things that it's not. In other words, you don't want a line or a line segment to also fit into your definition of a ray. I'll give you a couple minutes. Go. Charlotte, you're in the upper left-hand corner of my screen, so what do you got?
I said a line that has 2 points but goes on forever.
Okay, so how is that different than the definition of a line?
Well, a line doesn't have 2 points. It just goes on for forever. And then a line segment, it doesn't go on forever. It has 2 points. So I kind of tried to combine both of them.
How many points are on that line I just drew?
2.
Actually, there's an infinite number. I just made 2 of them special and gave them names. Okay? Understand the difference? There's a whole bunch of them there that I just didn't make special. It's like taking 500 students and then picking 2 of them out and giving them, you know, class president and class vice president. Okay? So how can we change what you did, Charlotte? Or do you want to blow it up and start all over?
I don't really know.
Okay. Megan, your turn. What do you want to do?
I just said a line that goes from point to point, but that is kind of the same as line segment.
Correct.
So I don't really know that.
Okay.
Something that has an endpoint and a continuous part.
Keep going. I don't hate that.
Yeah. Array is something that has 1 point as the endpoint of that line.
Okay.
Another part on the line, but one has an endpoint, the other just continues on forever.
That's a good building block. Okay, so it has an endpoint. I'm not real happy about that it part. We'll come back to that. It has an endpoint. And what'd you say then, Daniel? That's an E.
It has an endpoint and a continuous line on the other side of it.
Oh, no, you changed that. That's not what you said before.
A continuous endpoint and another point.
That's not, okay, wait, hold on. It has an endpoint and I thought you said something like, and it goes on forever.
Yeah.
Okay. Well, it definitely has an endpoint. In this case, it would be A. And it definitely goes on forever. Would a line fit your definition, Daniel?
No, because the line doesn't have an endpoint.
Okay. And would a line segment fit your definition?
No, because the line segment has 2 endpoints and does not go on forever.
Okay. Emily Stanton, do you like what he's done here?
Yeah, kind of. I had just added, there's an endpoint and then there's another point at the end of that point. It goes on forever, specifying that there are 2 points and not just one.
Okay. But actually there's an infinite number of points. I just gave this one a special name. Okay, good. What about this it thing, Daniel? I hate pronouns. I mean, what is it?
A line.
But that's not a line, it's array.
Array that has a series of points.
Okay. All right. So if I change it to a series of points, we're good to go. A series of points that has an endpoint and goes on forever?
No, it doesn't sound right.
Yeah. Okay, well, what if I do this? Now I turn that ray into a line, right?
Mm-hmm.
So if I started with a line and I erase this, now what do I have? Now it became a ray, correct?
Yes.
So what if we change this to a portion or a part of a line that has blah, 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 an endpoint and goes on forever?
Yeah.
All right.
Sounds good.
I like that too. That's good. All right. A portion of a line that has an endpoint and goes on forever. I'm going to add one more thing. Just tweet this in one direction. So it doesn't end up like a shotgun going in all kinds of different directions. All right, good. Well done. All right, notation. So before I give you the notation for array, you'll recall when we were talking about lines, we could say, oh, well, that's line AB, and that's the same thing as a line BA. Okay. The symbol for array is just like what you would think it would be. You take 2 points and you put array symbol over it. But it gets a little interesting. Is this the same thing as this? Put a question mark over that. John, are these two things the same?
No,
Why not?
not entirely sure, but I just felt like saying that.
Okay, we had a 50-50 chance.
Yeah.
Bobby, what do you got for me? Are those the same thing? Do you agree with John?
No, I don't think those are the same thing.
Okay, do you know why not?
Well, because the one they put a question mark on is, I guess, supposed to be an array.
Yep.
And the one with the one though without a question mark is supposed to be like a normal line.
No, they're both rays. It's a little hard to see, but there's a ray symbol over that one too. So that's a ray and that. They're both rays, but okay, so both of you are correct. These are not the same thing. Okay, so not the same thing. The question is why?
The direction of the ray symbol would have to be changed if it goes over BA.
Beautiful. Thank you, Emily. Okay. What this means what I have drawn here. Start at the point A, go towards B, go past B, and go on forever. This means go to the point B, start at B, go through A, and go on forever. Okay, they point in opposite directions.
Try to get something so that it's not supplementary in classes. That'd be awesome. Okay, team. It's lunchtime. Thanks for working hard. I think Bree has an announcement, though. You guys have to take her. Real quick, we're going to actually let you have
Elena?
But right now, we're going to have expressive therapy.
You're not muted.
Hello?
Hi.
Did I unmute? Sorry.
Yeah, you did. I don't know what I was listening to, but it sounded interesting. Okay.
My mom sent me something to watch. Sorry.
Gotcha. Okay, so A, B, and BA are rays that point in different directions. Now, when we change them, so for notation, the ray in the ray symbol must always point towards the right. Okay, so if you're talking about the ray CB, we're going in that direction. Even if the ray itself points to the left, this notation like that doesn't make any sense. Okay, don't do that. The ray symbol has to always point to the right. Okay? That's fairly confusing. Any questions on rays? So we take this line that goes on forever. If we chop off both arrowheads, we get a line segment. If we chop off only one arrowhead, we get a ray. Okay. We good so far? No other possibilities. It has two arrowheads, goes on forever. It has one arrowhead, it goes on forever and is a ray. No arrowheads, it is a line segment. And hopefully you realize that the only one that you can measure the length of is a line segment. Okay, this ray has an infinite length. That doesn't make any sense. A line has an infinite length. Okay, good. Let's move on. Now, this is a picture of an angle. Please write a definition of an angle. While you do that, I'm going to go get some more water. I'll be back in a second. All right, Lily, what do you got for me?
I said an angle is made when two rays intersect at a point.
An angle is when two rays intersect at a point. Almost perfect. The only stipulation I would change here is what point?
Is it a midpoint?
So again, somebody said, I heard two people say something.
A midpoint?
No, because rays can't have midpoints. Remember, they go on forever.
An end point?
Perfect. So we're going to change this at the endpoints of the rays. Well done. Because notice, they just meet at that same endpoint. So that's ray BA is intersecting the ray BC, and together we get the angle ABC. Okay, good. I got nothing else to say there. The rays, when you put them together to form an angle, the rays are called sides, and the endpoint is called the vertex. If you have one, you have a vertex. If you have more than one, you have vertices. That's the plural of vertex. Vertices. Okay. How to name an angle? 3 different ways. Okay. One way is to use the 3 points. You pick one point on one of the sides, you pick the vertex, and then you pick another point on the other side. Okay, now the reason that this is the preferred method is because in certain pictures, you can't just name it by the vertex because you'll have multiple vertices. And I'll show you what I mean in another picture. Another way that people like to name angles is put a number inside the angle and then just refer to it by the number. That's also sometimes a little tricky depending on what angles you're talking about. 2 and 3 are okay, it's just that 1 is our preferred method. In this picture, with just one obvious angle sitting there, I would probably use method number 3. But when the pictures get more complicated, you may have to go back to method number 1. Also, notice that this is interchangeable. As long as B is the middle point. Without the middle point there, it's not B. So in other words, if I'm talking about angle ACB, okay, that would actually be this angle. Because the middle term, the middle letter, I should say, is always the vertex. All right, what are the 4 types of angles, Leah?
Obtuse, acute, right angle, and I don't know.
Okay, 3 out of 4 is not bad. So let's go back to what's an obtuse angle?
An angle that is more than 90 degrees,
But less than?
but less than 180 degrees.
Perfect. What's an acute angle?
An angle that is less than 90 degrees,
But greater than?
0 degrees, or 180.
No, 0. That's correct. What's a right angle?
A 90 degree angle.
Perfect. And then the one you didn't mention is a straight angle, which looks like a line. Looks like a line. Acute angle, right angle, obtuse angle. Right angle usually has that little box down in there. In this class, we don't deal with angles bigger than 180 degrees. Other math classes you will, but for us, once it gets to 180, we're done. All right. We good? Okay. Now, you'll recall a while ago I talked about how to name the angles. When you start adding more angles to a picture, it gets a little confusing. Congruent angles work just like congruent sides. 2 angles are congruent if they have the same measure. So a 57-degree angle is going to be congruent to a 57-degree angle. How do we show that in a picture? Oh, hold on. Let me start with this. What's the difference between this and this? Okay. This is a physical object. It's the angle itself. This is a number. So this is like 57 degrees is equal to 57 degrees. Okay. Numerical value, physical object. How do we show that angles are congruent in a picture? You put a little mark down in there. If you have more than one pair, you just add more arcs. So then all the 2's would be equal. If you're feeling saucy, put a dash. It doesn't matter. It's just like tick marks. The pictures, or the tick marks match the tick marks. So no matter how crazy of a tick mark I get in here, I get a squiggly, then that's going to be congruent to any other angle that has a squiggly in there. Okay. And as the pictures get more complicated, we're going to have more and more tick marks in there. So you've got to get comfortable with that process. Okay. Angle bisector. Well, we know what a bisector is already. We've done a segment bisector. A segment bisector cuts a segment in half. Therefore, an angle bisector would cut an angle in half. Most of the time, our angle bisectors will be rays. Occasionally, they can be other things. It could be a segment. It could be a line. It could be a plane. But most commonly, we'll see a picture like we have there. The same relationship we talked about with segments also applies in this picture. So for instance, angle PQR is congruent to angle RQT. The 2 halves are equal. Or we could say that 2 times angle PQR is congruent to angle PQT. If I double the little guy, it's going to equal the big guy. Or angle PQR is equal to half of the big angle PQT. And all of those come about because of the angle bisector. All right. We talked about types of angles. Leah gave us that. Right, acute, obtuse, straight. Now we're going to start pairing angles up, and there's 5 different pairs that we're going to talk about. Okay, so here we go. Number 1 are called adjacent angles. What does adjacent mean, Danny?
Across from?
No.
Next to each other.
Next to each other, correct. Okay, so they're angles that are next to each other. They share a common vertex. They share a common side. So look at the picture here and compare it to the picture here, because the difference is important. In this picture, QR is a bisector. In this picture, it is not. And so the only statement we can make here is that angle PQR, this one, plus angle RQS is equal to angle PQS. This picture is similar to the betweenness we talked about with segments. 2 smaller angles add up to equal the big angle. Okay. But again, these are not equal. All right, so that's 1. Adjacent angles next to each other. That's it. Number 2, vertical angles. Don't get confused with vertical meaning up and down. They're just 2 angles that are across from each other. Okay, so angles 1 and 3 are vertical, and angles 2 and 4 are vertical. 2 pairs in that picture. Okay. Non-adjacent angles formed by intersecting lines. Okay, so angles that are not next to each other. 1 goes with 3, and 2 goes with 4. Number 3, linear pairs. Same picture as the last slide, except now we're taking angles that are next to each other. All right, so let's talk about angle 1 and angle 2. What's the relationship between angles 1 and 2, Mia?
They form a straight line.
Good. Keep going with that. So what else?
They're adjacent.
Good. Keep going.
Their line that they make equals 180.
Ah, there we go. Angle 1 plus angle 2 equals 180. Well done. Now, that's a really important point. Does everybody understand that? Give me a thumbs up before I move on. Okay, good. Mia, let's come back to you then. What's the relationship between angles 2 and 3?
The line they form is also equal to 180 degrees.
Okay, so angle 3 plus angle 2 equals 180. Okay, last question for you, Mia. What's the relationship between angles 1 and angles 3?
Are they vertical angles?
Good. What's their numerical relationship? Any idea?
They're congruent.
Good. Very nice. Okay, now you can look at the picture and see, yeah, these look equal. That angle looks equal to that angle, but we can also step over here and do a little bit of algebra and get that angle 1 plus angle 3 plus angle 2 plus angle 2 equals 360. I'm just adding those 2 things. Actually, you know what? I'm going to do it a different way. I lied. I'm going to use some substitution here. Angle 1 plus angle 2 equals angle 3 plus angle 2. Since they're both equal to 180, I set them equal to each other. Subtract angle 2, And sure enough, angle 1 is equal to angle 3. Good. So if I come back here to the vertical angles, we get the fact that vertical angles are congruent. That's called VAT. VAT stands for vertical angle theorem. Anytime you have vertical angles, they will be congruent. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Okay, we're going to use that later. Okay, so we got what? Vertical angles, linear pairs. Now we put that to work. Please solve that problem. Two things you're looking for. Look for x and look for angle CAT. It is currently 11:48. We will come back together in 5 minutes, which would be 11:53. Solve that problem, and then you got a couple of minutes to take a break. Get up and step away from your computer. I'm going to go walk around a little bit and stretch my legs. I'll see you in 5. Okay, I got 53. Let's go. Katie, what do you got?
I haven't finished. I know what I got for X.
Okay.
I just
So
plugging it in.
I don't really care about the number, but tell me about what equation did you set up to find x?
I did 16x minus 20 equals 12x plus 7.
Okay. 4x equals 27, so x equals an ugly number like 27/4.
Yeah.
Is that what you got?
Yes.
Okay, good. So tell me then, how am I going to find the measure of CAT?
I'm not sure. This is where I got stuck.
Okay, let's pass it off to Julia. What am I going to do with that 27/4 to find the measure of CAT, Julia?
I'm not too sure, actually. I'm pretty sure it's an easy way to figure it out. I just can't think of it right now.
I wouldn't say it's easy. Nia, what do you got? What would you do?
I found X, but then I didn't know how to find CAT, so I just kind of like stopped there.
Okay, Olivia?
So I plugged in X to 12x plus 7.
Nice.
And then I got 88. And
Good.
then I subtracted that from 180 and I got 92.
Perfect. By the way, I didn't talk about this, but I'm assuming you're all familiar with the degree symbol, yes? We're good there? Okay, good. Well done, Olivia. Katie, nice job also. But Olivia, I have a question for you. What's wrong with my picture?
I'm not sure.
Anybody else notice a problem with my picture? Okay, given this information, let's get this stuff out of the way. This is on me.
Angles aren't representative.
Ooh, who's talking?
Daniel.
Could you expound upon that, please? What do you mean?
The 88 degrees, what it's describing, does not look like 88 degrees, and the 92 degree angle does not look like 92.
Very good. This 88 degree angle looks like an obtuse angle. It looks like it should have a measurement of greater than 90 degrees. This angle that we just solved for has an angle measure of 92 degrees, but it looks like an acute angle. Okay, so now what do I do? Do I trust the numbers or do I trust the picture? The answer is you always trust the numbers. Okay, it's not beyond me to draw a picture that is not a very good representation of the actual numbers. Those numbers are perfect. Katie and Olivia knock it out of the park solving that problem. My picture is wiggity wiggity whacked. How big is this angle?
92.
92, good. Which would make this angle?
88.
88, good. All right, so we're good to go with example 1. Nice. Let's move on. Our fourth pair of angles, supplementary angles. Anybody remember what supplementary angles are? You might not have done this before. Two angles who add up to 180 degrees. That's it, plain and simple. Just any two angles, as long as their sum is 180 degrees. They don't need to be next to each other. They don't need to be adjacent. They don't need to be anything. They're just supplementary angles. And then, number 5 is complementary angles. Two angles that add up to 90 degrees. Those are our 5 pairs of angles. Now we take those 5 pairs of angles and we mix them all up and solve a bunch of problems. So if we go back to the one we just finished, there's a whole lot of stuff going on in this picture. We used vertical angles to solve this by finding the value of x, which Katie solved to be 27/4, I think. We used supplementary angles because once Olivia knew that this was 88 degrees, she did the supplement of, by the way, it's called the supplement of 88 degrees, which is 92, so she subtracted that from 180. Okay? Beautiful. More examples. Solve that one first, please. In this case, I just want to know x. Even though it says find the measures of the angles, I don't really care. You can plug it in to find out the angles to make sure it works out, but I'm most concerned about x. All right, who haven't we heard from? Alexander, what am I going to do in this problem?
You're gonna take 10x minus 5 in parentheses and add it to 4x plus 3.
Hold on, my 5 is horrible. Let me get caught up here.
It's gonna equal 180.
Well done. Okay, so these are two different angles here and here. What kind of angles are they? They are supplementary because they add up to 180 degrees. They are a linear pair because they're adjacent next to each other, and they add up to, and their non-common side is a line. Okay, so we can do the math here. We don't really care, but let's see. 14x is equal to 182, and therefore x. Somebody help me out, please. What's 182 divided by 14?
13.
13 exactly?
Yep.
Oh, okay. Beautiful. Good. Example number 3. Again, solve for x. Enya, what am I going to do in this problem?
You add 2x plus 2 in parentheses plus x plus 1 in parentheses equals 90 degrees.
Perfect. For Alexander and Enya, do I need those parentheses?
In this equation specifically, you don't necessarily need them.
Correct.
But if you're going to be subtracting the values, I mean, it's good to include them either way.
Well said. Right. If this turns into a different problem where you're subtracting, like he said, they should be in parentheses. 3x is equal to 87, so x is equal to 20. No, not 20. Yes, 20. Let's see. It goes in there to bring it to
29.
29. I knew that. I was going to get there. Thank you. X equals 29. Now, if you don't trust your answer, you could plug the numbers in and make sure they work. Okay, this would be 30. 29 times 2 is 58 plus 2 is 60. Oh, look, 60 plus 30 is 90. Woo! Come over here, 13 13 times 10 is 130, minus 5 is 125, and 13 times 4 is 52, plus 3 is 55, and last time I checked, 125 plus 55 is in fact 180. Woohoo! This is not needed, however, unless it specifically says find the angle measures, and in this case I just wanted to know x. Questions? Good. This gets a little ugly now, because everybody loves word problems. The measure of the supplement of an angle is 60 less than 3 times the measure of the complement of the angle. We need to talk about something before we solve this problem. If I have an angle, okay, let's call this angle B, and let's say angle B is 20 degrees. The complement of the angle is the angle that when I put it together, I get 90 degrees. So for instance, let me get rid of this mess. Okay, if this were 20 degrees, how big would this angle have to be? Perfect. Okay. So the verbiage says the complement of a 20-degree angle is 70 degrees. Okay. If I come over here and I make this equal to 20 degrees, then how big is this angle?
160.
Good. That's called a supplement. The supplement of a 20-degree angle is 160. Okay. Now, things get a little weird. What if this was x? What if this is x? Whoops, not x squared. Come on, Reedy. X degrees. How big is this angle then? Cricket, cricket. Well, if this was 20, how'd we get the 70? Subtracted from 90, yes? Well, then if I subtract that from 90, I get 90 minus x. How did I get the 160 over here? 180 minus 20 gave me 160. 180 minus x. And so what does that mean for us? Whoops. So if I come over here, if x is an angle, its supplement is 180 minus x. Its complement is 90 minus x. This is the key to solving these types of problems. We did the hard part already. And I'll say this 1,000 times, but in order to solve these problems, what you have to do is literally just write down what it says and then solve. Okay, so what does that mean? Well, I'm going to go back to the original problem here. I'm just going to read it off and write down exactly what it says. The measure of the supplement of an angle, I have that. It's 180 minus x. The measurement of the supplement of an angle is a fancy way of saying equals 60 less than. What function is less than? Hello? Is it still on?
Subtraction.
Thank you. Minus 60. 60 less than 3 times, that's multiplication, the measure of the complement. We have the complement right over there. Okay, so again, literally what I did is just read that and write down exactly what it tells me, knowing that is an equal sign, and you know that less than is subtraction, you know that times is multiplication. We get that. We can solve that. 180 minus x is equal to 270 minus 3x minus 60. I'm running out of room here. Let's see, bring that over there. I would get, let's bring this over here. I would get 2x if I brought that over there. Then that's 210 minus 180 would give me 30. So x is equal to 15. Find the measure of the angle. That's x. It's 13. What's the complement? 75. 90 minus 15. What's the supplement? 165. 180 minus 15. And these types of problems will ask you for all three of them at various points in time. You will find these problems fairly frustrating. You need to remember two things. This stuff over here and writing down exactly what it says. Okay, you got all this? Can I move on? Okay, thank you. We've talked about perpendicular already, but now that we're talking about angles, we can throw it back in there. These two lines are perpendicular. There's a little box down there. That forms a right angle. It's equal to 90 degrees. All of that is the same thing. Forms four right angles. Why don't we write all four things in there? Because then it just becomes a mess. So we don't need all that. Just one box represents all of those angles being 90 degrees. I think we talked about this, but I'm not sure. There is a symbol for perpendicular, which is an upside down capital T. Did we talk about this already? The upside down T?
Yeah.
Okay, good. All right. And again, we know this already. We can talk about the slopes, but this isn't a slope problem. This is an angle problem. So we don't care what the slope of line L or the slope of line M is. We just care that they're perpendicular to each other, that they form a 90-degree angle. Lot going on in that picture. You'll also notice that there are two variables. Okay, so you're going to have to find both x and y. And I think this is our last example for today. So again, solve for x and for y. Solving for x is similar to the problem we already worked through. Y is a little bit different. Emma.
Yep.
X or Y? Which one do you want?
X.
Okay. What equation are you going to set up to solve for x?
To solve for X. I just said 3x plus 6 plus 9x is equal to 3y plus 6.
That is not a false statement. Okay. But there is a problem with that. How many variables do I have here?
2.
2. How many equations would I then need?
2.
2. I don't have 2. Unless you can come up with something else. Do you notice anything else in this picture?
No, not really.
Anybody want to jump in here?
3x plus 6 plus 9x equals 90 degrees.
Good. Okay, that's solvable. 12x is equal to 84, so x is equal to 7. Okay. How do I find y?
plug 7 in for x at the 12x equals, or at
Up here?
the top equation.
Sure, sure, sure. Any other ways to find y?
Set 3y plus 6 equal to 90.
Good. Any one of those works. Let's see, 3y is equal to 84. 84 divided by 3 is 20, I don't know, what is it?
28.
Thank you, 28. Okay, good. Good. Oh, so again, if we go back to that original equation is true, but it's not solvable. We need to do a little bit more work to get that because we would need another equation. Okay, but once you get that other equation, all the puzzle pieces fall into place and we're good to go. Questions? Beautiful.